Hello and welcome to 5.6 Rules of Exponents and Scientific Notation. Let's get started. So problem set 1 says evaluate each of the following expressions. Evaluate means to find a numerical answer. So we look at this, we're saying take this big number and multiply it by as many times that we see to the number above it. So this is really saying take 2 and multiply it 2 times. Just like 2 to the third would be multiplying 2 by itself 3 times. So we would say 2 times 2 is 4, times 2 is 8. Now keep in mind that would not be 6 because that would be 2 times 3. We want 2 multiplied by itself 3 times, giving us 8. Okay, with number 2, what we want to do is look at this and see with our order of operations that exponents comes first and then multiplication of the negative. So we actually want to keep the negative away first and then evaluate 5 squared. So we have negative times 5 times 5 equals the negative times 5 times 5 reduces to 25. So we have a negative times 25 or just negative 25. A lot similarly looking, we have example 3, where the negative 5 is actually included in the parentheses. So this really means that negative 5 should be multiplied by itself 2 times. And as you know, a negative times a negative gives you a positive. So now we just do our simple multiplication of 5 times 5 is 25. So our answer is just a positive 25. Looking at number 4, what we want to do is take the number inside the parentheses, 1/2, and multiply it by itself as many times we see here, which is 3. So we're going to take 1/2 and multiply it by itself 3 times. And when we do that, we're going to get 1/2 times 1/2 is 1/4 times this remaining 1/2. What happens when we do this? We get 1 is the numerator and 8 is the denominator. And that's the answer. There are 6 rules of looking at exponents that we want to keep in mind when working with exponents in our problems. They are the product rule, the quotient, the zero, negative, power, and power of 1. So the product rule says if you have 2 bases that are the same but the exponents are different, that you can actually add the exponents, keeping the base the same. With the quotient rule, it's a lot similar, where you have 2 bases dividing each other, hence the quotient, where they have different exponents. So what you can actually do is keep the base but subtract the exponents. But note that a cannot equal 0, because that would make this fraction undefined. Okay, with the 0 rule, you have a base, any base, with a power of 0. And what's going to happen is your answer is going to become 1. But keep in mind that your base does not need to be 0. Okay, with a negative, that means you have some base to a negative power. What you can essentially do is place it over 1. So you can say 1 over a to the nth power. And again, keep a anything but 0. Okay, the power rule. That means you have a base with an exponent times another exponent. And what happens is you keep your base, and then you just multiply the two exponents together. And finally, you have a power of 1. That means you have a base being raised to the first power, and all it does is equal that base. If we apply our rules we just learned, we have for number 1, 2 to the 4th times 2 to the 2nd power. So what we can do is we have similar bases, take our exponents and add them together. So that's all we're doing is simplifying these expressions. With number 2, we see that 10 to the negative 1th power times 10 to the 2nd power. Since we have same bases but different exponents, let's actually add these powers together. So we're going to get 10 to the first power, or just 10. Okay, for number 3, we have same bases, the negative 5th base, but our exponents are different. So what we can do is have our numerator minus the denominator. And what's going to happen is we're going to have negative 5 to the negative 4 plus 9 power. Because if you notice, our negative times negatives. So negative 5 to the positive 5th power. And I believe for our last example, using our rules that we learned, we have the same bases. And if you note that this does not have 1, but actually has a power of 1. And this is a 3. So we want to keep our same base, but subtract our exponents. So we have 2 to the 3 minus 1 power, or 2 to the 2nd, which can reduce to 4. Our final topic for chapter 5 includes scientific notation. It's writing really small or really large numbers in powers of 10. Here are a set of strategies you can look at. So we want to write scientific notation for 3,000. The trick is to write the number that does not have zeros, or the part where it stops at 0. So we have 3 times, and then we have our power of 10. Now we have to write the power of 10 using the amount of zeros. So there are 1, 2, 3. So just write 10 to the 3rd, because that would yield 3 zeros. And when you multiply 1,000 times 3, you get 3,000. Okay, for this, we're going to need to use negative powers, because this is creating a really small number, which would in turn create a fraction. But we have a decimal here, so this is what we have to work with. So our number does not include zeros, it would be the 2, times 10. Now we have to place our negative since we're going backwards, and now just count the number of places past the decimal that you are until you get to this number that you have written down. So we have 1, 2, 3. So this would be the scientific notation for this number. That would be 2 thousandths place. For number 3, what I like to do is find the numbers that do not have the zeros attached, so I stop it right here. So I'm going to use 1.55. I want to write these as small numbers, so I want to put the 0.55 in there. So now we have to use our 10, and to do that, you actually want to count the number of places you have to stop before you get to this 1 right here. So you have 1, 2, 3, 4, 5, 6. So we're 10 to the 6th. For number 4, we have a very small number, and I like to work with putting the decimal right there. So I have 1.88 times 10, And now just count the number of places before you get to where that 1 ends. So 1, 2, 3, 4, 5, 6. Remember, we moved backwards because we're a very small number, so we have to have a negative. And for our last numbers, we have been given scientific notation. We have to write these in standard form. So we have a 0.6 or 6.1, and we have to tell how many numbers we want to move back. Since we have this negative, we're going to move in the backwards direction. So we have 1, 2. So we move our decimal place back 2 places. So the new standard form would be 0.061. And for example 2, we have 8.47, and according to this, we want to move our number larger 5 places. So we have to move 5 places past the decimal. So 1, 2, 3, 4, 5. And for each of these spaces that we've made, we're going to fill in with zeros. 1, 2, 3. So we just filled in 3 zeros. So we have 847,000 as our answer in standard form.